In this video, we're going to talk a little bit about how Fulcro works from just a state management perspective. So this video is not intended to show you how you would actually write Fulcro applications, but to get you more familiar with the concepts that you need to understand really well to be able to work with Fulcro. They're not terribly difficult concepts, but if you don't start here, you'll be confused. Dive right into it. So Fulcro def.sc makes React components. These components are the class-based components. They have lifecycle support, and they pass their data through from parent to child as props. Now, in your traditional React ecosystem, when you've got some subtree where you're trying to deal with full stack data, you do something like you deal with it in lifecycle methods, or you create a higher order component and have the higher order component manage that state and feed it to that subtree. Fulcro takes a different approach. It does allow you to manage things as a subtree, but it doesn't want you to have to deal with the complexities of the higher order components or having data potentially duplicated in multiple caches, all of the chaos that kind of ensues when you don't have a solid data management model. But let's just start with the idea of how Fulcro is working. So you create an application, that application holds on to a state database. And you'll notice the requires up here where I'm grabbing different namespaces from. And I've got this thing attached in the REPL. Let's verify that. So if I try to run an expression here, I get 1 + 1. Oh, nope. All right, let me restart that. I had reloaded and I was concerned that maybe that was the case. Okay, so talking to the browser. All right, so now if I go over here and I tell the REPL to switch to this namespace, and I put my single page application. This single page application is just a map. And you shouldn't necessarily assume you know what's in this map. There are some things that are considered sort of publicly accessible, etc. But if you just look at, say, the keys in this map, there's oh, that should be, why am I, oh, I hadn't loaded the namespace. All right, there we go. Oh, how about we use the right variable name? There we go. Okay, so it has several top-level keys, and you see one of them there is the app prefixed state atom. And let me thread that and deref it. So you can see when I first start up, there's nothing in there. And I could do something along the lines of make a div here and say show the string of props, and then I could do something fun like if I reset the app, I'm sorry, let me unthread this. I could reset that to something along those lines. You can see that's there, and then I can ask for a re-render, and you'll see that data just pop up as a string in the browser because I'm directly rendering it. So that's the first thing to understand about Fulcro, is Fulcro essentially takes data from this top-level state atom and sends it through props. Now, it does something a bit more advanced to this database before turning it into props, but right now we haven't told it how to do that. So at the moment, all it will do is just pass the entire database as it were into this top-level component as just a raw map. So let's say that I created some tree of things. Let's say I was working with some root of a tree. That's going to go as sample. Let's call it sample. And then sample maybe has a child that's a single person. So I could define, a person component with a person ID and a person name, and I'm going to drop these bits for the moment. could come in here. So when you define a component, that's exactly like a React class. And so you need to be able to create elements, and this factory thing gives you back a function that will create React elements out of that class. And this key function is for setting the React key when there are adjacent ones in a list, which is a requirement of React. So that's just basic React kinds of things here. So if we reset our state, schedule render, we'll see that data come out in there. And so we could pull the sample props out there, which is a person, and then say UI person sample, and we could schedule a render of that. The hot code reload did that for me, and you saw the UI update. So as I save this, I'm racing Shadow CLJS for a build and hot code reload, so I don't actually have to go and do that schedule render when I'm making that sort of change. So you can see at the moment I can just further nest these things and make some subtree, and very often this is exactly what you do in some subtree of React. You create some subtree and then you're manipulating a subtree. So maybe this person has some cars, and so there's a car with an ID of 22 that has a model, and then of course I can continue up this tree and again I'm gonna leave that bit blank for the moment. And so now I've got a car factory, and so now I could say that this person has some cars. And pull them out that way. And then of course I need to actually put that in state, schedule a render, and now I've got that subtree. So I'm literally just building, as you can see in parallel, a tree of UI with a tree of data. And one of the primary things that Fulcro is trying to help you with is dealing with this tree. And so what it wants to do is define a database that you can use on the client to have a few features that are really critical for dealing with data. And so when you think about a database, and you think about kind of a right-sized database for UI work, you at least want a few features. So if I've got various UI concerns spread all over my screen, two of those different concerns, two subtrees of my UI, might be trying to display some aspects of the same thing at the same time. For example, I might have a person list item that shows just the name of a person in some list, and when you click on that one, to the right a form shows up that's the person form that lets you edit all of their details. Those pieces of information are on the screen simultaneously, and I really don't want there to be caching concerns over those. I would like those to really be the same thing in the same database. So normalization is number one. There are a number of other concerns. I would like these things to be indexed in some way, shape, or form, and normalization kind of ends up giving us that for free. And then of course I want to be able to pull from that database what I actually want into the UI, and I'd also like some leverage in terms of creating graph queries for the server, in having my UI components be able to declaratively say, here's what data I use, so that when I go to pull data for that component into the UI, I can pull just what it needs. So this is one of the advantages of a graph based system, that GraphQL came up with, and Fulcro from Netflix. Like, this is the idea, is let the UI ask for what it needs, and then we'll satisfy those queries from the server, which you can do very elegantly with Pathome. We'll talk about that in a later video. So I've got this data, it's structured in a tree, and what I'd like to do is normalize that. And so the first thing I need to do is decide, well, if I'm using closure data structures because, well, they're immutable, they're fast, they're already here, they don't have additional dependencies, what format could I use to stand for this? And so what Fulcro does is it says the database should be flat. We should identify entities. So for example, this person entity, we need two things to identify a particular entity for it to be relatively well indexed. One is the name of a table to put it in, and the other is an identity for that particular instance to put it in. And when I say table, I really mean map. In this particular case, that's what we have. We have either vectors or maps, and maps are indexed by key, which is a really nice property. So if I come up here and tell Fulcro a query, first of all, here are the attributes that I care about for this particular component, and I'm not going to, well, I am going to deal with the subtree here in just a second, but let's just deal with these two attributes to start with, person name and person ID. And I can also declare an ident. Now this ident parameter in this map, query and ident both have alternate interpretations. You can specify them multiple ways. The easiest way to specify an ident and the recommended way is to specify it as a keyword, which is the name of the ID field of your entity. So I'm going to use person/ID as the table name, and I'm also telling Fulcro here that I want it to use person ID, the keyword, to look up the ID of some incoming entity to figure out where it goes in that table. So I'm kind of doing double duty. If I've defined that, and it's going to complain at me because I told it I wanted cars destructured, but I didn't query for it. This is trying to help me not make a mistake there. So let's comment out some bits of this. Okay, so Fulcro comes with a function called merge component. And this can take an app or anything that can get you to an app. App is the easiest one. It wants the name of a component that represents the shape and ident of the data you're about to hand it, and then you simply hand it the data that represents one of those components. So if I've told it to merge a person into my database and a person has an ID and name, and so first off let's just clear the database. So the database is empty. If I render, there's nothing in there. If I merge this component and then I look at the current state of the app, oops, I can see that what I get is a table named person ID. It's a top level entry, which is a map keyed by the IDs of the entities in it. So you can see that one is the ID and then there's the submap that is the entity. This is a cumulative, so if I merge another person, now I've got two people in the table. If I merge another person, etc. Okay, so that's step one. I can take a particular entity and I can put it in the database at a particular point. The next thing I need, of course, in order to build a graph of any kind or a tree, is an edge. And so edges are represented as a vector of the table and the ID, which gets me to any one of these entities. So for example, the ident of person 1 is a vector person ID 1. And that would get me to this particular map just via a get in on the state atom. So that's how I make an edge. So now I can draw any graph that I want based on that. Now, we had said in our, well, we haven't said yet. So our root component needs to be able to grab some edge and perhaps some properties of its own. And by the way, the root component corresponds to the root of the database. So it's the only one that's not normalized. So it does not get an ident. That's a common mistake, is to give that an ident. Do not do that. No idents for root. But it does need a query. And the query will typically start off with something like a join Joins are represented as maps with a key and a value. So a join on root/person, and then a subquery. So here I would say like person/ID, etc. But what I really want is to know what person itself, the UI component, wants to know. Oops, what did I screw up with? This is it trying to help me not mess up. Okay, so the get query function literally goes to that class and pulls its query. So you can see I can run get query straight on a person, it'll give me the query of that. The other thing that get query does though, and this is a really important thing, is it adds some metadata. So if I look at the metadata of this query, I'll see that the metadata of that query knows which component it came from and some extra advanced information we're not going to talk about yet. This is the important trick. When I've got the query, which is what this function grabs from this component, it can look at the query in a nested way and figure out which piece of the data goes with which part of the query, and from the part of the query it can ask which component, and from the component we can ask to get an ident based on some props. So that's kind of the chain of events there. So I'm going to merge a component, and so let's say I say I want to merge the sample component. Well, the sample component should look like there's a root person, because that's what the sample component says it queries for, and then under that there should be a person. So let me clear the app database again, see that it's empty, run that, look at the current state again. Oops. Oh, I can't use merge component on a root. Sorry, that's a no-no. Merge component wants to find the ident of this top level map. There's a different way of doing a root merge. So let's stick with what we had here. We can chain it down a different way. Okay, so I have this one person that I'm merging. Let's go back and add car back in. That will do us a better job. So here I'm going to do the same thing. I'm going to join person cars to a get query of car, and car I'm going to say has an ident of car ID and a query that needs to at least include the car ID, and it looks like I'm asking for the car model out here as well, so I should grab those pieces, and then I should destructure cars up there so I've got it flowing through. So now, and again, we don't actually need any of this UI for any of this to work. We could actually just clean this up a little bit for the purposes of a demonstration. I can look at the state of my app, I can clear it, I can look at it again, I can merge a person with a subtree and it'll normalize both entities into their correct tables and create an edge. And notice this is a too many edge. It's a vector of idents. And that was detected automatically because I put a vector of entities in the thing I was merging. Fulcro doesn't have schema for these, so if you were to put a single car in there, even though it's named cars, it's not interpreting your English. If I were to merge that, then what I would see is a single edge to one edge. So you getting it right is well, up to you. So if you intend for that to be a too many edge, you need to make it a too many edge. All right, so that's the basics of normalization. Oh, I was going to show you, right? Get ident of a car. If I give it an empty map of props, I'll get an error. Oops, wrong key. Oh wait, I have to prefix that with. Actually, I shouldn't get an error. Actually, if I give it an empty map, I was giving an error because I was using a function it didn't know about. If I give it an empty map, it goes looking for the car ID in this empty map, finds nil, and makes me a bad ident. right? So if you ever see a warning or an error in the console over here about there being a nil second element in your ident, it basically means you passed some empty props through while Fulcro was trying to calculate an ident, and it couldn't calculate one that it thought was sane. So if this had a car ID of 1, I'd get that. If it had a car ID of 2, I'd get that, etc. And of course, the rest of the props that are in this map just don't matter. I'm making an ident. So the normalization, really that simple. Walk the map while simultaneously walking the query, looking at the metadata on the query to find which component is responsible for normalizing that particular aspect of the data tree, and then normalize it. And so what you end up with is this nicely normalized database. And now doing things like modifying the data of a particular entity. So let's say we go back up here and let me just hit undo for a bit and let it put the UI code back. We'll keep the query stuff in here. All right, so notice there's nothing in the UI here, and part of the problem is our root doesn't have an edge from root person to the actual person. We have a person in the database, but no edge. And merge component actually supports an additional parameter that lets you target the particular thing, top level thing that got merged to a particular edge in your database. So in this particular case, I could put that person at root person, and now when I merge that, you see it immediately shows up in the UI. If I look at the current state, you see there's now an edge at the root of the database. This isn't a table now. These are tables. This one's not. That's one slightly confusing thing about Fulcro, is the tables exist in the root node of the graph, as well as root edges. Now, if I wanted to, for example, merge a car, with another Ford. That's going to put, oh, wrong ID, I've already got 22. Let's do 42. That would have overwritten the other one, would have changed the name, but that's not what I wanted to show you. Here I'm adding a new entry to the car table, but if I just did that, let's go ahead and do that, it's not hurting anything. All right, well now I have that second car in the table, but it's not joined into the graph anywhere. What if I wanted to join it into the graph here? And so this is the next realization you should have. Since this is a flat database, it's tables, IDs, entity, and then any join is an ident that takes you back to the top. Hooking any subtree anywhere into the entire graph is just a matter of a three-segment coordinate. The table name, the ID of the thing, and which field you want to mess with. So let's say this supports an append. I want to go to person ID 3 and add that car to their cars. So now if I look at the state, you see the UI already updated. I can now see that I've added another edge to the graph. Now this applies for load, this applies for server pushes, this applies for data entering into Fulcro in any way, shape, or form. You can always say, I've got this data, it's represented by this subtree of the UI, merge it in, and that'll put it in tables, and then connect it to the graph in the following places. And so the functions that let you, quote, connect the graph, or the thing you just loaded into multiple places, it accepts multiple arguments. So that makes it very flexible. Also, if you think about refactoring, when you go to move some UI tree from one place to another, the higher order component thing is nice in that you pick up the higher order component and you move it to a different location, and okay, now you've taken the kind of the data stuff with it. It's not nice in that if you want to pull some subtree under that higher order component that's managing the data off and put it someplace else, well, you've now disconnected it from its data model. In Fulcro, the disconnecting it from the data model is as simple to heal as tacking in a new edge in your database graph. So you pick up something from one place in the UI, put it someplace else in the UI, correcting the data model, even if the data was loaded somewhere else in a disconnected way. You can heal this data graph very, very easily usually. Of course, sometimes lifecycle and things mess with you just as it would in any other system. So how does the data get here? When does it get here? Those kinds of things. Timing issues are still timing issues. But in terms of compositional issues, the data is composed in this very nice, easy to deal with, normalized form that's fast. It's fast to query. It's fast to update. If I want to change a person's particular attributes, it's just again, another, so let's say we put person age in here in the query. Right, so I've just specified a new thing that I might want from a server, that I might get from a server push, that I might want to manually put into the database in just one declarative step. I already know where it's going to normalize. And in fact, if I want to go look at it in the database, I can go look for that particular entry in the table and see what's there. So let's go back down here and let's do a little more magic. Now again, this is not how you write Fulcro apps specifically, but I just want to show you that it's very simple data underneath. So if I run swap on an atom, I can modify what's in that atom. So I can say assoc in at person ID 3 person / age 22. And so now I've modified the database and go look at the current state. It echoed it back at me. Oops. It helps if I put the assoc out there. Okay, so that looks better. So the person now has an age. Oh, and I crashed the rendering with that snafu. I had to reload the browser, so now I don't have anything in my app state. Append that there though. I wanted to replace root person. Alright, so there we go. Now we got our age in there, and you can see it's rendering properly, our state's proper, and the point I was trying to make is that now I can do things like update person's age and bump it by 1. And since I'm not going to get if I can get a hot code reload, it'll re-render. Should have re-rendered there. Person age, did I put it in the right place? Nope. Person ID, oh, wrong person. Ha, person 2. It's incremented a couple of times. Look at the state, save, let it hot code reload. There we go. Now we see the number updating. So state manipulations are always very, very simple operations because the data is always in a table at some ID and then some field. And then manipulating these edges, there are helper functions to let you integrate an ident into an edge, remove an ident from an edge, etc. So I guess in summary, Fulcro lets you materialize your views as both data, queries, and structure all together, and materialize those into a normalized database that's very easy to work with. In future videos, you'll see how we actually use these things to write a full-blown application, but this should get you through kind of the hardest part of understanding how the magic of normalization really isn't that magical, how you end up with a database like this, and then how you can work with it. Well, obviously you're not going to use reset, swap. You will use swap, but you'll use it in a more controlled environment. So, till the next video.